Hello, friends. Welcome to my command center. And this is a live stream, actually. And we have something very, very interesting to discuss today. And that is about the supermassive black holes. And you know that these black holes are some of the most interesting object. But I think the topic of discussion today is how they got so big. And luckily for us, we have come across nearby supermassive black hole also in a small, rather small galaxy. And this supermassive black hole just drifting towards the Milky Way, and it's a small dwarf galaxy, not as large as Milky Way, but even though this is a small galaxy, it is supposed to be a dwarf galaxy, but a spiral galaxy. And believe it or not, at the center of this spiral galaxy, which is very close by, we have another black hole which is same size, as much as same size as the Sagittarius A star. And as you know, that Sagittarius A star is the large supermassive black hole that exists in the center of our Milky Way. So we are lucky to have another similar size black hole to be drifting close to us so that we can study that one. Why this is more important? Because to study Sagittarius A star, which is our own supermassive black hole at the center of the Milky Way, is rather obscured because of the lot of dust cloud in the line of vision between us and the Sagittarius A star. So it is rather difficult to study the Sagittarius A star. So we are lucky we find this galaxy drifting very close to us called Leo 1. It is in the neighborhood, and it is drifting towards us. It's a small dwarf galaxy, and it is a spiral galaxy, very similar in shape and size, but rather smaller as compared to Milky Way. Now, the biggest question is that how a small galaxy like this can harbor a supermassive black hole as much as the size of Sagittarius A star, and what are the processes, these things become so large. So even though this small galaxy has a very large supermassive black hole as large as the Milky Way, I think this discovery will give us more understanding, more avenue to basically perform our research, and eventually understand a little bit more about the supermassive black hole, how they form, how they were created in the universe, how they got so large. And by doing that, the scientists have also found that the galaxy has less of metal. The metallicity of this galaxy is quite low. Now, let me explain for the benefit of the viewers that the metallicity, as per the scientific phenomena, anything which is not hydrogen or helium is known as metal, or classified as metals by scientists, simply because given the right temperature and pressure, these things start behaving like metal. Even carbon can be behaving like metal. So the constitution of different stars in the galaxy, if they have high amount of higher elements like carbon, nitrogen, etc., scientists classify those stars with having higher metallicity. So when the universe was born, the metals were not there. It was mostly hydrogen, and then hydrogen created helium. So these are the only two gases known to man, known to science, that exist. But in this galaxy, the Leo, we find that the metallicity of the material which is available in this galaxy is rather low. That means the material by which this galaxy has been formed is a primitive nature. It's mostly hydrogen and helium, and yet it has a supermassive black hole at the center of this small spiral galaxy, which is very surprising that even though this galaxy is made of only gases, most of the material in the galaxy is mostly gases, which is hydrogen and helium, and very little higher elements, and has very little metallicity, yet it has a very large supermassive black hole at the core. And by doing the age analysis of this galaxy, we find that this is not very old galaxy. Just like our Milky Way is at least estimated to be about 12 billion years old, Leo 1 is not more than 5 billion years old. So this is a fairly young galaxy, and still have even if the estimate goes off by 10 to 15%, this galaxy is not older than 6 billion years. So it is relatively young. The galaxy itself was formed when our sun was taking shape, and therefore this is a young galaxy. And how this galaxy got us time to build 400 million solar masses size of a black hole in the middle. So I think this is approaching near Earth. This is creating a good scenario for humans to study the supermassive black hole. And probably one of the hypotheses is that the star formation in Leo 1 is now stopped. So the core of the Milky Way is sort of silent, not too silent, but it is sort of silent. It has eaten a lot of free gas which was available in the galaxy, and the stars are very bright, very shining very brightly. In fact, the brightest star in this galaxy is very close to this central core supermassive black hole. So I think a lot of research needs to be done, and a surprising thing is that a small galaxy in the neighborhood has a very large black hole in the middle, as big as this Sagittarius A star. So in our neighborhood, we found that the largest black hole that exists is the Sagittarius A star, followed by the central black hole of Leo 1. So this is a very interesting find, because no other galaxy in the neighborhood has such a large black hole in the middle. And this is creating a lot of excitement among the scientific community, because they will be able to study something new, and they will be able to throw light on the formation of supermassive black holes. So friends, if you have any suggestions, any questions, feel free to send in your comments. And as always, thanks for watching, and I will meet you tomorrow at 3 live again with something more interesting about space time. Until then, have a nice day, and keep rocking.